As we witnessed in Segment 1, the eruption of the Hunga Tonga Hunga volcano was not only spectacular, it was mysterious in its sheer violence. Scientists around the world began to ask the same question. Why was this underwater eruption so explosively powerful? To find the answer, we need to dive, quite literally, beneath the ocean's surface, into the heart of what makes underwater volcanoes so dangerous. Unlike land-based volcanoes, submarine volcanoes are often hidden beneath hundreds or even thousands of meters of water. When they erupt, the interaction between hot magma and cold seawater creates a unique and volatile dynamic. It's not just about heat, it's about pressure, chemistry, and physics all colliding at once. When magma, molten rock from the Earth's mantle, rises to the surface and meets seawater, it causes what scientists call phreatomagmatic explosions. These occur when intense heat causes the water to flash into steam instantly. That sudden phase change from liquid to vapor creates a violent burst of energy, far greater than the lava itself might produce. But in the case of Hunga Tonga, something more happened. The Hunga Tonga Hunga volcano sits along the Tonga Kermadec subduction zone, one of the most active tectonic areas in the world. Beneath the ocean floor, a massive supply of magma had been building up for years, slowly pushing toward the surface. Unlike typical eruptions, this one occurred in a shallow marine environment, just about 150 to 200 meters below sea level. The sweet spot where pressure is low enough for an explosion to breach the surface, yet deep enough to trap pressure long enough to make it catastrophic. When the eruption finally happened, the result was an enormous blast of steam, gas, and ash, ejected vertically with such force that it reached the mesosphere, something never before observed. But what really amplified the eruption was the geometry of the volcano itself. Recent bathymetric surveys showed that Hunga Tonga had a caldera, a collapsed volcanic crater, that was partially submerged. This allowed seawater to rush in and mix with the hot materials as pressure increased, essentially creating a giant pressure cooker under the ocean. Once the system failed, the trapped gas expanded violently, and the explosion was released with a power equivalent to several hundred Hiroshima bombs. This interaction between magma, seawater, and confined gas created what some scientists described as a perfect storm of volcanism. The energy release was so intense that it generated shock waves in the atmosphere that traveled around the planet multiple times. Meteorological stations in Europe, Australia, and even Antarctica picked up the wave patterns hours after the eruption. Another surprising factor was the amount of water vapor injected into the upper atmosphere. Unlike sulfur dioxide, which reflects sunlight and cools the planet, water vapor acts as a greenhouse gas. The Hunga Tonga eruption sent nearly 10% of the total stratospheric water content into the atmosphere in a single event. This has potentially long-lasting implications for global climate dynamics, especially stratospheric heating. The explosion also sent a tsunami across the Pacific. Waves were detected as far away as Peru and California. But the real devastation was felt in Tonga, where the force of the wave, coupled with the ashfall, disrupted nearly all communication, damaged water supplies, and left thousands in crisis. Perhaps the most fascinating aspect was how quickly all this occurred. Within just a few minutes, satellites were capturing images of a massive cloud expanding with perfect symmetry. Scientists later analyzed those images frame by frame to estimate the velocity of the ejected material, some traveling over 300 meters per second, or close to the speed of sound. As we learn more, it becomes clear that this eruption wasn't just rare. It was unique in modern history. Not since the eruption of Krakatoa in 1883 had the world seen such a large-scale explosion from a volcanic source. And unlike Krakatoa, which relied on reports from ships and observers, the Hunga Tonga eruption was witnessed by the entire planet. through the eyes of satellites and sensors in real time. At Infinity Beyond, we continue to explore the unseen forces shaping our planet. Stay with us, because in the next segment, we'll reveal how scientists are using this eruption to rethink how we monitor volcanic threats under the ocean, and why the next eruption might not give us any warning at all.